Good morning, my dear students. Hope you all are fine in this pandemic situation and also after the attack of Amphan. So, today in my class, I want to discuss we want to discuss about aromaticity. So, when we start to discuss about the aromaticity, the first question come to our minds that what is aromatic compound? Very simply, aromatic. So here, if you just remove the TIC, that is AROMA. So this is pronounced or word as a aroma. Now, this aroma means that that is some organic organic smelling or getting good flavor. Now, if you think that what are they, like oil of wintergreen, here it is the very simple compound. We know that salicylic acid, then the ester methyl ester of salicylic acid, that is methyl salicylate, is known as oil of wintergreen, which is very commonly it smell like iodex. You have all have idea. Then another one is the cinnamon. These all are found in our spices, Indian spices. Then yes, you have very familiar with this compound. Very familiar with the compound vanilla. This is the structure of the vanilla which you find in our biscuit or ice cream and lots of things. Now, if we want to get definition of aromatic compound, then very simply we can say the benzene and benzene like derivative are known as aromatic compound. It's a very simple definition, but it is not the perfect definition. Now, Huckels, one of the great scientists, who gave some notes or some point to define a aromatic compound. Please be note this. If there is a condition, these are not actually the definition, but the condition to be a organic compound and aromatic compound. The first thing is the compound must be cyclic. So the compound must be cyclic. Then number two is the compound should be planar, and compound will be conjugated. And the most important thing, that is, it should possess 4n plus 2 pi electrons. So 4 point number 1, the aromatic compound have 4n plus 2 pi electron. Number 2, it should be conjugated. I will say you details about what is conjugation. Now then the compound should be planar, and another thing, that is cyclic. So 4 point, if a compound satisfy all of these 4 point, then we will say that this is aromatic compound. If the next anti-aromatic compound, the same thing, but the number of the electron when will be 4n, then it will be anti-aromatic compound. Is this clear? So where n is the integer, it started from 1 2 3 4 etc. So we get a light idea about the aromatic compound. When I go to the direct example, then it will be clear which are the aromatic compound and which are anti-aromatic compound and others. Before going to detailed discussion of this aromatic and anti-aromatic, there will be other compound, that is, which is called non-aromatic, that is in between aromatic and anti-aromatic. Now in concern of the stability, so aromatic compound are more stable, or you can say more stable than non-aromatic compound, and anti-aromatic compound are least stable. So if you think, that is the first example, that is aromatic, that is benzene, it is highly stable, because we know that each pi bond can hold 2 electron. So here in benzene 3 pi bond, so it contains 6 pi electron. Now 6 pi electron means 4n plus 2, that is 4 plus 2, where n is 1. Then it actually satisfy the one of the condition of the aromatic compound. Now you are saying that this is a cyclic structure. Yes, second point also satisfy the point. Then this double bond have a conjugation. Conjugation means if you rotate this pi bond, so now suppose in this figure the pi bond are present in the position of carbon number 1 and 2, and 2 to 3 there is a no pi bond, but we can exchange this pi bond. There's no problem, you can know resonance and other things, so by which we can change the position also. So that's why it is called the conjugated system. So when it is conjugation, that is one pi electron will be replaced another pi electron, or one double bond is replaced by a single bond, and single bond is replaced by the double bond. This type of the thing is called conjugation. So then obviously this benzene is an aromatic compound, and it is very 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 much stable. Now in case of the anti-aromatic, this all things are the same, that it should be a conjugation, it should be cyclic, it should be planar, because conjugation is not possible if it is non-planar. So here the conjugation is present, but the number of the electron is 4 pi, that is 4n pi electron. So that's why it is another compound, and it is a very less stable, and it is called anti-aromatic compound. Now these are the octa tetraene. So here also the same thing, that is, it is anti-aromatic in this figure, but it will not stay in this figure because it is unstable, but after that it will be twist, or basically it will be stable at the bend form, that is the next structure. So actual the cyclooctatetraene is not anti-aromatic, but we can say it is non-aromatic. Clear? So aromatic is a 4n plus 2 pi electron, anti-aromatic 4n electron, and it should be same thing, the conjugation and this thing, and it should be planar. But anti-aromatic compound will be non-aromatic compound if it is not planar. Clear? Now here, that is cyclopentadiene. If you consider the cyclopentadiene, so there are 4 pi electron, but there is no conjugation through the cyclic structure because one of the carbon is the sp3 carbon. So here the conjugation is not possible. So here this compound is called non-aromatic compound. But when it form a cation, that is removal of the one of the hydrogen from by base, it form cyclopentyl cation. Now here the 4 pi electron, and yes, the top carbon atom is sp2 hybridized, so there will be a chance of conjugation. So yes, it acts as a anti-aromatic compound. But again, if the hydrogen leave the system by keeping its electron, then it will be form cyclopentadienyl anion. In that case, 4 pi electron from double bond and 2 pi electron from the anion. So there are the 6 pi electron, and this structure is planar. So ultimately its aromatic character. So cyclopentadiol anion is aromatic, but cation is anti-aromatic. So here obviously the cyclopentadiol anion is more stable than cyclopentadiene and cyclopentadiene cation. So here from the structure you can see that this first one is the non-aromatic because there is no conjugation, but in case of the cation there will be conjugation, so obviously it will be aromatic. But in the last case it will be anti-aromatic. So if I conclude the thing, that is aromaticity, the term aromaticity is used to describe the aromatic compound and properties. Yes, this vocal rule obviously very important, and in addition to that we can say the aromatic compound are highly stable, undergo substitution reaction rather than addition reaction. So as it is stable, it cannot lose it pi electron, so it is better the compound undergo substitution reaction, so that cannot try to break the aromaticity. So they try to remain or try to unalter its aromaticity because they are stable. And another fact is that the CC bond length 1.39 intermediate between a double bond and a single bond, which signifies that there's a uh, conjugation is taking place and which will lead to the stability of the compound. And these are the structure of a benzene, where the pi electron are distributed above the ring and below the ring. That is in the if you consider the benzene is present in a particular surface, then above this surface there will be electron density or cloud, and then below the surface there will be electron cloud. I am not going to discuss detail about the cyclobutadiene. Okay, here if you see the electronic distribution of the cyclobutadiene, then we'll say or see that 2 pi electron take place as a bonding orbital, and 2 electron are in the non-bonding orbital, and these all are in the singlet state. So we know that if the electron come to the bonding orbital, then the compound will be stable.